Hi, my name is Dr. Tishan, and in this video we are going to work with functions and tangent lines. Our function is missing a number though. We have k to represent the missing constant in our function. So we're going to need to find this missing number such that our tangent line truly is tangent to our function. We're going to do two examples. Here's another one on the backboard. Let's take a look at example number one. The function given to us, f of x, is k over x. We've got to find out what k is, but it's k over x. The tangent line is y equals negative 3/4 x plus 3. We want to find the number, the constant k, that's missing such that this tangent line truly is tangent to this function. And before we begin with the algebra of it, let's take a look at what the graph might look like so we can see, get an idea of what we need to do here. Okay, so the function, first of all, this function, it's a hyperbola, isn't it? K over, when you have a number over x, you got a hyperbola. If k is a negative number, it'll be in the second and fourth quadrants. If k is positive, it'll be in the first and third. We don't know what k is, so I'm just going to draw a scenario. Maybe it's in the first quadrant. In the third quadrant, maybe it's in the second and fourth, but this is our function right here. It's a hyperbola, all right? Okay, and then we have, there's our tangent line. The slope is a negative slope, negative 3/4 with a positive y-intercept. So if I have this scenario here, then it looks like here's my tangent line right here. This is my y, and this is my y equals my tangent line. All right, so negative 3/4, okay, negative 3/4 x plus 3. So here's my tangent line, all right? So this point on the function, let's go ahead and call this point x for the x coordinate and f of x for the y coordinate. So here's the point on the function, okay? All right, and if I give it its tangent line name is just going to be x for the x coordinate and y for the, because it's f of x function value is called y, all right? So just want to look at this picture right here. And so that point of tangency, what is true about that point of tangency? Because that's what's going to help us set up our system of equations that we need to solve. So what is true for this point right here, okay? First of all, can you see that the function value is equal to the y-coordinate on the function and the y-coordinate on the tangent line are the same thing, okay? So our first equation, when we solve this, we want to set up our system of equations. Our first equation is to equate the function with the tangent line. Our first equation is going to be to take the k over x, and we're going to equate it with negative 3/4 x plus 3. Set the functions equal to each other. At this point right here, the function and the tangent line are equal. So you want to set these equal. So step one, you're going to set the functions equal to each other. All right, the function value set is equal to the f of x equal to y. What else is true about this point right here? Well, the slope of the line is negative 3/4, and the derivative of the function, the slope of the function, are also equal. So the next thing we're going to want to do is we're going to want to take the derivative of the function and set it equal to, I'm going to call it m for the slope of this line. You want to set the derivatives equal. The derivative of this function with k being a constant is going to be negative k over x squared. That's what the derivative of this function is, okay? And the slope of this line is a negative 3/4, all right? So to solve this for unknown k, we want to find our constant k. You want to set the functions equal to each other. Step one, you're going to set this equal to that, all right? And you want to set the derivatives equal to each other, all right? So set the derivative. Now k is a constant, so to find the derivative, see where I can work this out, okay? So k is a constant, so f of x, all right, is equal to k times x to the negative 1 power. So just the work to find this derivative, if you want to see where it came from, just use the power rule, bring the negative around front, so it's negative k times x to the negative 2. Remember, k that we're looking for is a constant. You treat it as a constant. So when you bring the negative 1 around front, multiply, you get negative kx to the negative 2, which is negative k over x squared. So you want to equate the functions, okay, and you want to equate the derivatives of the functions, their slopes. It sets up a system of equations for you, and we are going to solve the system of equations. We want to solve the system of equations right here to find our value k, which is what our job is. We're going to find the value k, we're going to find the number that goes here, such that we have the tangent line to the curve. All right, so let's solve the system of equations. All right, so we can go to maybe we can take the second equation right here. So let's take negative k over x squared, all right, equals negative 3 over 4. And let's maybe cross multiply, simplify this, okay? So negative 4 times k, negative 4 times k, all right, is equal to negative 3 times x squared. So we can cross multiply here. Anytime you have a proportion, the product of the means equals the product of the extremes. You can cross multiply and then solve for k. So now our k is negative over negative, so positive 3/4 x squared. This is what k is, okay? Now we need to figure out what the value is, but we're going to solve a system of equations. So I use this second equation to come up with an expression for k. I'm going to take this and plug it into my first equation. My first equation is k over x equals negative 3/4, all right, x plus 3. We're solving a system, so I'm going to take this expression right here, substitute. Instead of putting k over x, I'm going to substitute 3/4 x squared, okay? Substitute that k value in because we're solving a system of equations. Negative 3/4 x plus 3, just bring the right-hand side down. One of the x's cancels here, okay? So you have 3/4 x, all right, is equal to negative 3/4 x plus 3, all right? So what do we want to do here next? Let's go ahead and add 3/4 x to both sides, all right? So let's add 3/4 x to both sides. So 3/4 x plus 3/4 x, that is 6/4 x. 6 over 4, which is 3 over 2. So we have 3/2 x equals, well, they cancel, so 3. We want to know what x is. Okay, so now we would want to multiply both sides by the reciprocal, multiply both sides by 2/3, multiply both sides by 2/3, and this will give us x, okay? So here, anytime you have a fraction times a variable, you can undo it by multiplying by the reciprocal. You can see the 2's cancel, the 3's cancel, okay? So x is going to equal 2/3 times 3. That's going to be 6/3, which is 2. So x is 2, but we don't want to know x. Our job is to find k. All right, well, we know what x is. If we know what x is, if you can follow back up here, we can easily get k by just plugging in for x, okay? So what is k equal? Well, k is going to be 3/4, okay, times x squared, all right? We computed x to be 2, so you make that substitution here. So 3/4 times 2 squared, and so it looks like right here, 2 squared is 4, and the 4's cancel, so k is 3. So k is a positive number. K is 3. When k is equal to 3, this is when our tangent line to the curve will be equal, our tangent line to the curve will be truly tangent to this function right here, this hyperbola, right? So if the function is 3 over x, okay, so it would look like first and third quadrant, 3 over x, then here is the tangent line. It would actually come into contact at the point of tangency, all right? We have another example on the back board, so I'm going to flip the board over to do another example. Let's take a look what we did here, though, all right? We want to find the missing number, the missing value in the function such that the tangent line in the function, tangent line is tangent to the function. So to do that, you're setting up a system of equations, okay, based on what is true about the point of tangency. What is true? First thing that is true is the functions are equal to each other. So one of your two equations, you're going to just take the function and take that equation, the tangent line, you're going to set those equal. Now you have an equation with two unknowns, okay? So you can't solve an equation with two unknowns, all right? But we can generate a second equation. Second equation, what else is true about this point right here? Their slopes are the same. The derivative of the function, the slope of the tangent line are going to be equal at this point. So you take the derivative of the function, we use the power rule to get that, set it equal to the derivative of the tangent line, if you want to call it that, the slope, okay? Set the slopes equal. So now what do we have here? We have two equations with two unknowns. You can solve system of equations, and our job is to find the k. You know, we had to find the x first to help us get to the k, all right? Let's look at another example. All right, so let's look at another example. These are a little bit busier of examples. So I have another example on the back board here. All right, so now we have a parabola for this function. This function f of x equals x squared minus k times x. We have a parabola opens up, all right? And we have tangent line to the curve, okay? So parabola, somehow the parabola, this is a parabola opens up, Okay, so I won't even put it on an XY scale. And then we have a positive slope with a negative y-intercept, so maybe the tangent line's somewhere over here, okay? So and here's our point of tangency. We want to find the value of k. Our job is to find the value of k such that this tangent line truly is tangent, hits the curve at exactly one point. It's not going to be over here and all over, all right? So you remember what we need to do? We're going to set up a system of equations. Our first equation is where we equate the function values, okay? And our second equation is where we're going to take the derivative of the function and set it equal to our slope. We're going to equate the functions, we're going to equate the slopes, okay? What is true about this point of tangency right here? The y coordinate, the functions are equal, okay? The y's are equal, f of x and y are equal, and the slopes are equal. All right, so let's do the first one. So we're going to take x squared minus kx. We're going to take the f of x. We're going to set it equal to 5x minus 4. Set it equal to 5x minus 4. Okay, and then we want to take the derivative. The derivative of x squared is 2x. The derivative of k times x, where k is a constant, is going to be k. And then we want to take the slope of the line. Here are the two equations. These are our two equations, all right? And we're going to solve the system. These two equations right here, let's go ahead and solve the system. So we'll plug one function into another, all right? These are not linear, so the elimination method probably won't work so well. So let's go ahead and maybe take one of these two equations. Let's take the second one and solve it for k. All right, so let's subtract 2x from both sides of this equation. All right, so the 2x's are gone, so you have negative k equals 5 minus 2x. And then divide by negative 1, so you have k is going to be 2x minus 5. Okay, so this is what our k, so let's go ahead and make the k substitution into the first equation. All right, so let's do that. I'm going to move over here, okay? So let's take our system of equations right here. We're going to take the x squared, we'll take that top equation minus k times x, all right, equals 5x minus 4, all right? And let's go ahead and we're going to substitute for k, all right, we're going to substitute. So you have x squared minus k times x is 5x minus 4, all right? And we're going to take the k and we're going to substitute for k. Let's substitute in the 2x minus 5. 2x minus 5 goes in for k. See that? All right? Remove the grouping symbols. So we're going to want to distribute this x, okay? So we have x squared minus 2x squared, all right? And then minus a negative. So we're distributing the negative and the x, aren't we? Okay? So that gives us a positive 5x. Be careful there, okay? Equals 5x minus 4. And let's go ahead and combine like terms. All right, so x squared minus 2x squared, so we have a negative x squared, all right? When you take away the 5x's from both sides, okay, the 5x's cancel out, all right? And then you can add 4 to both sides, all right? So we're here, when we collect all the like terms, combine the x squareds, combine the x's, we're here, okay? All right, and this is the same thing as 4 minus x squared, isn't it? Okay, so when is this equal to 0? Well, you can factor, so 2 plus x and 2 minus x, or you can add x squared to both sides. Whichever way you decide to work it out, x equals 2 and x equals negative 2, okay? So we have two values for x. We have two values for x that's going to, which means we're going to have two answers for this one. We're going to have two k values, all right? So we will have two k values, all right? And let's find out what they are, all right? So these are the two x values, aren't they? We want to solve for k, all right? So let's start with at x equals 2. Well, when x equals 2, okay, what is k? Well, to compute k, we have it right here. To compute k, all right, we're going to take 2 times the x and subtract 5, all right? So to compute our k, we're going to take 2 times our x of 2, and we're going to subtract 5. So here, k is going to be a negative 1. 4 minus 5. So here, k is negative 1. That's one of our answers, all right? And then let's go ahead and compute k. What about at x equals negative 2? When x is negative 2, what do we have for k? Well, we know that k is going to be, k is 2 times x minus 5. All right, so k is going to be 2 times negative 2 minus 5. All right, so k here is going to be a negative 4 minus minus 5, okay, maybe I'm anticipating here. So our k value over here is negative 9, all right? So the two values that we generated, okay, so the two values we generated, this answer right here, k is going to equal negative 1, and k equals negative 9, all right? So these are the two answers that we have for this curve right here, all right? So this is our parabola right here, so two different values. When k is a negative 1 and when k is a negative 9, those two situations where the curve would be will generate a y equals 5x minus 4 tangent line. You have two values for k. Sometimes happens when you have quadratic expressions, all right? So just to review, just to recap, okay? We want to find the missing value in the function such that our line here is tangent to the function. We have the equation of the tangent line. We've got to find the missing value, right? The missing constant. So you want to first of all take the functions, okay? What's happening at this point? The functions are equal and the slopes are equal. So you're going to set the function equal to the equation of the tangent line. That's your first equation. And you have an equation with two unknowns. Can't solve an equation with two unknowns. You need to generate a second equation. Well, at this point, the slopes are equal. The slope, the derivative of the function, is equal to the slope of your tangent line. And so you're going to do that to generate your second equation. Your second equation, an equation with two unknowns. So we have to solve the system. Many different ways to solve the system. So I chose to find k from the second equation and plug the k expression back into the quadratic, the first equation. Plug it in. I solve for x. Two values for x means you're going to have two values for k that will work here. Okay? All right, well, that's it for this video. I'm in my backyard, so I hope the background noise wasn't too bad. Beautiful day out. I mean, it's a rainy day, but rainy days are still beautiful. So I hope you are well, and take care. Thank you so much for watching. Bye-bye.